In this video, you'll see how we generate electricity with electromagnetic induction. To begin with, we'll start off with two permanent magnets. As you can see, we've got them lined up with the north and the south pole facing each other. In this way, you can see the magnetic lines of force are shown to be directly between the north and the south pole. In between the poles of the magnet, we'll place a conductor. This can just be a piece of copper wire, and connected to each end of the piece of wire is a voltmeter. And this is going to indicate when we start movement of that wire as to which direction and how much voltage is going to be generated. From this you can see, as the wire was moved in the downward direction, the voltmeter moved to the left-hand side, but as soon as the motion stopped, the voltmeter returned to zero. As the conductor was moved back up through the magnetic field, the voltmeter now showed a voltage reading to the right-hand side. And once again, as soon as the motion stopped, the voltage returned to zero. This is all well and good to demonstrate voltage being generated, but it's not very useful to anybody. It's such a small amount of electricity that we need to find a way to be able to create something worthwhile. To increase the amount of electricity we can generate, we can continue to use the same permanent magnet, but now we use a coil of wire which increases the length of wire which is under the influence of that same magnetic field. Here you can see it's been drawn from a side view so that it's a little easier to see what's happening in our diagram. And we'll begin the description with the permanent magnet shown at right angles to our coil of wire and a voltmeter connected so we can measure and see what's happening in our coil. At the bottom of the page, you'll also see a graph. On this graph, we can have a look at the voltage and see how the voltage reacts as the magnetic field approaches and leaves the coil of wire. We can see the change in the voltage as it occurs. That was very quick, but what we can see happened was that as the north pole approached the coil of wire, the voltage started to climb. When the north pole was in line with the coil, the voltage was at its maximum, and as it started to move away from the coil, the voltage then went back down to zero. Now we're going to have a look what happens when the south pole begins to approach the coil. As you can see from this shot, the voltage generated was in the opposite direction as what was generated in the first one. This has only been a very brief overview of electromagnetic induction and how we generate electricity. If you wish to do any further study, there's a great deal of information available and certainly a lot more in-depth information. I hope this has been of some use to you. I hope it can help you begin to understand how we generate electricity using this method. Thanks for watching. Bye for now.